So we are continuing with the tutorial PDF of Python documentation. So we are up to lambda expressions. Lambda expressions are small anonymous functions that can be created with the lambda keyword. This function returns the sum of two arguments. So this is a function, just a lambda function starting with a lambda keyword, and then these would be the arguments. We don't need parentheses for arguments for lambda functions. They are just separated by like comma separated values. Then we have the colon and the function definition itself, so what it would return. Lambda functions can be used wherever function objects are required. They are syntactically restricted to a single expression, so just a single expression, nothing more than that. And semantically they are just syntactic sugar for normal functions. They are just like normal functions, but we can write normal functions in a more concise way. That's just with lambda expressions. And like nested function definition, lambda functions can reference variables from containing scope. So yeah, these can lambda expressions can also like refer variables from the namespace, enclosing namespace. So this function would have enclosing namespace of this make incrementer. So we can take a look at this by the function given in the example right here. So we have the def keyword for defining a function. We have the function name itself and the parameter which it takes, n, just one single parameter, and then it returns a lambda function which takes in x as input and returns x plus n. So n is a variable from its the lambda function's enclosing scope, which is make incrementer, but it can still access it, and x is just the parameter which is given to the lambda function. So when we define this function and then store it in f by giving it an argument, so f equals make incrementer 42. So this returns make incrementer 42 returns a lambda function which takes in the value x and then returns x plus n. So when we do f0, so this is f which has lambda function in it. If we would have to print just f in this line, we would get a lambda function. I can show you that in a moment. But when we invoke then the f with any value, the value goes in with the name of x for this lambda function, and then it accesses the n from its enclosing scope, which is 42 right here, and it adds the value which we provide in this argument. And for this function call, the value would be 42, since x plus n, which would be 0 plus 42, is 42, and here it would be 43 because 1 plus 42 would be 43. So that's for this example. The above example uses a lambda function, lambda expression to return a function. Another use is to pass small function as an argument. So we just talk about this. This function, the make incrementer function, here would be like an example of higher order function. Higher order functions are just functions who return which return another function. So yeah, that's a definition of higher order functions, which return another function and can be called. So another way is to pass a small function as an argument. So pairs, we have a list here, list of tuples, and pairs dot sort, we are sorting this list with the key of lambda. And lambda expression we have, it's where is this? Yeah, syntactically restricted to a single expression. So this is just a single expression of a lambda function. Let me explain you how this is. So lambda, we have the keyword right here, we have the argument which would be passed, so the pair, and from the pair we get the first index. So the key would be the first index of the pair, pair being this list, and the first index for every element. That's what we are passing as the key to the sort function. Sort is a built-in function for lists. We can talk about it later on. And for this one we are getting the first argument, so that would be, this is the 0th argument, this is the first argument. So for every tuple, the first argument would be like for this one it's 1 as a string, 2, 3, 4, so on and so forth. And when we then sort pairs and then print pairs, we get 4, 1, 3 and 2, because it's sorted on the basis of the letters right here. So F comes first, then comes O, then comes TH, and then comes TW alphabetically. So that's how it is sorted right now. So that's how you can pass lambda functions whenever function is needed. So lambda functions can be used wherever function objects are required. That's a pretty good example for this line. Next is document strings. Let me just show you lambda functions first. This is an example of how lambda functions can be used in a more concise way instead of regular functions. Like lambda functions can be sometimes more informative, and just we can read them better. So yeah, we can first comment this out and try with our normal function. We have data right here. Data is a list of tuples, and sort, we have a function named sort key, takes in item and returns the first item, same as our another example given right here. Yeah, right here. So here it returns the first index, and we sort data. So sorted data contains the sorted this is a function, a built-in function. Sorted takes in a list, and next would be the key, at basis of which the list would be sorted. So sorted key, we return the first element, and then it would be sorted based on of these values. So if we then print sorted data, because this whole function creates a new list which is inside of sorted data, and if we run this, we would get the list, but it is sorted on the first argument right here. So 4, 1 would come first because 1 comes first. Next is 2, next is 5, and next is 8. So that's how. But if we comment this one out and we uncomment this, which would so these lines of code and these lines of codes are the same thing. They do the same thing, but this is syntactically so much more readable. So sorted data is a sorted list of data, and with the key of a lambda function which takes in item and returns its first index. So takes in data in this in this example, and returns its first element. So sorted data would now have the same value. I can run this as well. The function ran, and it has the same value right here. So it is much more readable than this way of writing, and it is much more concise as well. So we can use we should use lambda expressions wherever we want to use function objects, and it is just one liner or something. So lambda expressions are much more useful in that way. Doc strings, we talked about it earlier as well. Any function can have doc strings in them, or just by convention. These are just like they do nothing, but they are just mini documentation inside of your program. Let's just read this. So if there are more lines in the document string, the second line should be blank, visually separating the summary from the rest of the description. Following line should be one or more paragraphs describing the object's calling convention and its side effects. So yeah, doc strings are just mini documentation for your functions or classes or something. Python parser does not strip indentation from multi-line strings. String literals in Python. So multi-line strings would be the triple quotes, triple single or double quotes. Here it is triple double quotes. You can see there are 3 double quotes, and there can be 3 single quotes as well. That's the same thing. For the first non-blank line after the first line of the string determines amount of indentation for the entire doc string. We can't use the first line since generally adjacent to the string's opening quotes, so its indentation is not apparent in the string literal. Just some gibberish right here. It's just that this doc string, some parsers, Python parsers, they detect the doc strings and generate the documentation for the functions or such, and we can access the doc string of a function or any object really by the dot what's it called, dot special character, and then underscore doc underscore. So yeah, we get it as it is, nothing's changed, because like we have this inside triple quote, so we have the space and everything preserved. And next is function annotations. Function annotations are just a way to tell the user of the script that like what's expected in the function. So annotations are stored in an underscore the annotations attribute of the function as directory and have no side effect on any other part of the function. Parameters annotations are defined by colon after parameter name followed by an expression evaluating the value of the annotation. So these are these are parameter annotations. I mean, these are parameters and these are parameter annotations which are defined by a colon between them, and this would be the type of parameter the function is expecting us to provide. But this in no way specifies the like necessity to provide a string. We can provide any argument, but just annotations are just there to tell you what the program expects from you to input or something. And return annotations are defined by literal this arrow symbol, so this dash and then greater than symbol. So this is how we can specify return annotations and their type right here. Just beside the function definition arrow and then the like the return type of that function, just so that the user would know what this function returns. This in no ways like specifies what it should return. It just says that it will, I mean, just an annotation, nothing not like enforcing the function to just take in strings or return strings. It's just for like what's it called, I mean, just for our information, my brain stopped working right there. Followed by an expression between the parameter list and the colon denoting the end of def statement. So yeah, this is the end, and in between the end this colon which would then denote the end of the function definition, start the indentation for the function body. We have in between the return annotation. Following example has required argument and optional argument and return value annotated. So yeah, required argument right here doesn't mean like we put in string, so this argument should just be provided with a string. No, that doesn't mean that. Required argument means that this argument doesn't have a default value, unlike this argument which has the default value of x, as we discussed in the previous video. We provide default arguments in the function definition by just assigning the value, so equal sign and then any value you would like to assign it. So return value annotated, so this is the return value, just self-explanatory actually. And the intermezzo coding style, this is just a proper way to write Python code. You can read through this. This has nothing to do with learning Python. This is just these are just best practices to write like concise and formatted Python code. So you can look through this 4.9 in the tutorial PDF that that should be followed. So next is data structures. We have lists here, and list data type has more methods than append, which we saw previously. It has extend. It takes in an iterable, extends the list by appending all the items from the iterable equivalent to len a, and then equals iterable. So you should know what this does. You should know what this line of code does. If you don't know, rewatch the previous videos which has lists in it. So this basically does that a list named a at the starting index of length a till the end. So end would be length a minus 1. So just at the end of the list we add iterable, and iterable would be any sequence in Python which can be iterated. So that can be a list, a tuple. It would just add those values right here. Can be a string as well. Insert. These are just self-explanatory methods. You can look into those yourself as well, but this I can just run through these fast. It inserts an item at a given position. This would be the index, and this would be the item which you would have to insert at the position, equivalent to a dot append x. So this would be equivalent to a dot append x, not every index insertion, because this inserts at the length of the list, so that would be at the end of the list, and appends at the end of the list. So yeah, as you can see here, add an item to the end of the list and equivalent to this. And just removes from the end of the list first item from the list, and whose value is equal the first item from the list whose value is equal to x. So yeah, it has an argument here, so it would remove x, the first x it finds in the list, and raises a value error if there is no such element in the list. Pop just removes the item at a given position and returns it if no index is specified. So if we have something like this, the function called pop with no arguments, it removes the last item and returns it, and raises an index error if we don't find the the list is empty or the index is outside the list range. Yeah. Clear just clears the list. It deletes all elements in the list and just returns an empty list. Index, this doesn't return an empty list. This just modifies the list and removes all its elements. And index, what is this? X, start and end. So return 0 based index in the list of the first item whose value is equal to x. Yes. Raises a value error if there is no such item. Optional argument start and end. So we can provide x, and it will find the index of x in the list, the first index of x, and we can provide optional argument start and end to to specify that if we want to search just in a slice of the list and not in the whole list itself. Return index is computed relative to the beginning of the full sequence rather than the starting argument, rather than the start argument. Yeah. So yes, we can look into this list index x and start and end. We can take a look. List.py. So for a list equals just say 1 2 3 4 5 and 6 maybe, and then list.index can say here index of 3, which would return 2 to me. Let's just run this. Oh, we'll have to print it. Print it. Yeah, we get 2 and it returns the first index. So if we had a 3 right here, it would still return 2. Yeah, just as expected. And if we give it a start and end, which should be the second and third argument right here, so if we give it a 3, just start. Let's see if it like understands the end. Yeah, it understands and returns 5. So yeah, it would like, as I had the understanding, it returns the index computed relative to the beginning of the full sequence rather than to the start argument. So it won't start from the index 3 right here, so won't say like 0 1 2 3. So this is the first element. Then for this slice of, we are starting from this slice, right, counting from this slice. So that's why we don't get this, I mean, what are we searching for? 3. So we don't get this 3, and we get the value of this 3, but it returns the index value, so returns the index based on the whole list and not just counting from the slice where we started it from. So not from index 3, it starts from right here, doesn't start from 0 1 2 3, so it doesn't start from here, because then the value would be 1 instead of 5. Got it? So yeah, list count x, so returns the number of time x has appeared in the list. If we do count x right here, yeah, if we do count and remove the second element, because count doesn't have a second element, it doesn't expect it, so it would give us 2, still 2, because there are 2 3s. If we give it one more, it would be 3. So that's self-explanatory. And sort, as we saw, sort the list of items in place, and the arguments can be used for sort customization. See sorted for the explanation. Sorted is just a built-in function which takes in a list and then a key. So yeah, this takes in 3 arguments. This would be, the first would be like any number of arguments you give to it, and then there would be like, what's it called, keyword argument named key, which is set to none by default, and the keyword argument reverse, which is set to false by default. So let me show you the example right here. If I say list.sort, provide it no argument, we'll get a sorted list. Oops, why didn't we get a sorted list? Does it return anything? Oh, returns in, it does it in place, so it won't work like this, because in place meaning this function doesn't return anything, it just modifies the list itself, so this won't return anything. That's why we get none. And yeah, so that's, we just have to print list right here, that would do it. If we do this, we would get the sorted list right here. If we provided the key, I mean, what should be the key here? Key, I guess nothing. Key would be none, just none. And then, I mean, we can just not provide this, and the reverse would be true. We did this. Oh shoot, it should be for this list.sort. Yeah, so reverse true. This should be sorted in reverse order. If we had a tuple for some reason here, let's just take a small example for this, or just take it from here. Where did we have it? Right here. From right here to, so pairs, and print pairs. Reverse is true, and the key is, yeah, we can use the lambda function here, right, as well, right. So the key would be lambda, and then we have the what do you have, index maybe here, and the index So item here in the first tuple. Let's just do it this way. Yeah, so we have a tuple right here. What does this shadow? Oh, built-in name tuple. Okay, doesn't matter. It should refer to the local namespace and override it. And yes, so yeah, is this right? Yeah, is this is correct. I was confused because like why it was it was sorted in reverse because I had reverse as true. That confused me. So yeah, pairs are now sorted by key, their first key, and in reverse. So that's the sort function of list. Let's just go there. Reverse just reverses in place. So in place meaning it reverses the original list and doesn't return a new list. So that's in place for you. And copy, just a shallow copy equivalent to this. We know this. You should know this by previous videos. Oh, the examples were right here. I didn't have to go to PyCharm to explain this, but yeah, you got it, so no worries. Notice that methods only modify the list and return no value. They return the default value none. This is by design, so for all mutable data structures in Python. So they return none because they just do this all stuff in place. So they modify the original list, so that's why they return none, and the original list gets modified. Another thing you might notice is that all data can be sorted and compared. For instance, none, hello, yeah, and sort because integers can't be yeah. If you have different types of data in the list, which you can have, so it then doesn't know like on which basis different data can be sorted. So yeah, it can't sort it that way. Also, there are some types that don't have defined ordering. Yeah, imaginary numbers. Yeah, we can't compare imaginary numbers. So if we can't compare, we can't sort, or yeah, we can't sort. That's it. Using lists as stack. So stacks are so simple. Uh, it just made me laugh that I forgot to put my glasses on before I started recording. So yeah, we can get back to studying. Using lists as stacks. Stacks are like very basic data structure. They just have three methods: append, pop, and what was the peak? Yeah, we had peak, but I guess we don't have peak here in Python. Lists method make it very easy to use list as stack, where the last element added is the first element retrieved. Yeah, LIFO, last in first out data structure, stacks. And to add an atom to the top of the stack, we use append. Yes, we do. Append just appends to the end of the list, right? So that would be the top of the stack because it is a last in first out data structure. So whatever we put in last would be like first to get out when we pop it. And pop just pops out from the stack from its end and returns the element to you. So that's how we can like pretty easily implement stacks using lists. We don't have peak method in Python. I don't think we do, but if we do, just forgive me. So using lists as queue, that was it for stacks. Pretty basic data structure implementation derived from lists. And using lists as queue, so it is possible to use a list as queue where the first element added to the list would be the first out. So FIFO data structure, first in first out, whatever you put first would be first to get out. Yeah, so Eric here is first, John is second, Michael is third. So when we pop out of the list, I mean queue, it would be from right here. So Eric would get out, then John, then Michael. just as a queue at any store or something. You uh, you have a queue right there, and the first person gets their billing done and then gets out. Other person just does the same, and the last person has uh, everything last. So yeah, queues basically just queues in real life. So however, lists are not efficient for this purpose. While append and pop work from the end of the list, at the end of the list are fast. Doing the inserts or pops from the beginning of list is slow because of all the other elements that would be shifted by one. So yes, when we in a list, when we try to insert, so that would be this insert. Where was it? Insert. Yeah, insert ix. So index 0 and x element. So yeah, this thing insert at the front of the list, and yeah, that would like lists are pretty bad at it, because we would have to then shift every element to the left for an element to be at the 0th index. So that's big of n, like n times complexity. So that's time and space complexity. If you know it, you'd know. Implement a queue using To implement a queue using collections.deck, which was designed to have fast appends and pops from both ends. Yeah, we can do it as this. Collection is built-in module, and from collection import deck. It does that. It imports the deck collection from collections module, and we can then implement a queue as a deck, double-ended queue, which is the full form of deck. It's a double-ended queue. We can append to it. Appending adds to the start. So so they arrive, meaning just appending to the start, and pop left pops from the left. So we would get Eric, because he was added first, so he gets out first, and append adds to the end of the list as first in first out. So yeah, these three were before these two, then Eric is the first one to get out, and pop left is John gets out, because wait a minute. Oh, okay, pop left. I just thought this was pop right for some reason, so sorry. Yeah, both are pop left, so Eric gets out first and John gets out second. Pop right won't really be a method for queue, because it would be for a deck but not for a queue, because decks are double-ended and queue is just first in first out. So yeah, just pop left for a queue, and then we print the queue. We get deck of Michael, Terry, and Graham. So these two were just popped. That's right. So list comprehensions are next. List comprehensions are pretty concise way to create lists. When you know there is a pattern in creating lists, you can create them by list comprehensions. For common applications, there are the common applications to make new lists, where each element is a result of some operation applied with each member of another sequence or iterable, or to create a subsequence of those elements that satisfy certain conditions. So yeah, if there's a pattern in it, you can create it by list comprehension if you wanted to create a list with it. We have squares right here for x in range 10, so from 0 to 10. This is exclusive, so that's why 0 to 10. We have, yeah, I explained range function to you, so I won't do it again. Watch the previous videos. And squares dot append x squared 2. This puts 2 to the power of x, so x squared. Yeah, for 0 to 9 it would do it and append to the squares list. So we would get this, the list of squares from 0 to 9. And note that this creates or overrides a variable named x that still exists after the loop completes. Okay, and we can calculate the list of squares without any side effects using this. So for this we would have the x in a namespace, as you would actually know. uh, the interpreter started right here. This is the primary prompt. Secondary prompt, we know what the interpreter is. This was the first thing we started on. So the x would be here if the function if the if the program goes on, x would still be there in the namespace and taking extra space. So the variable named x still exists after the loop completes. That would be correct if the program was much longer, but here it just stops. So not yeah, till the interpreter we exit the interpreter, the x variable is still there. And can calculate the list of squares. Yeah, no side effects would be this, just a list comprehension. And oh no, this is not a list comprehension, this is just some functions, more concise way, but worse than a list comprehension in a readable manner. So list, we are creating a list from the map of lambda, which takes in the value of x and returns x squared for the range of 10. So yeah, we are mapping these two values and creating a list out of them. So x would just go from this range, and it would the lambda would return this value for this map function, and it would then create a list out of it. So we would get this same list out of this, or equivalently you can use a list comprehension, which is this. Looks pretty pretty concise and small. We have the square brackets at the end, denoting that it is a list. A square is a list, and it would return this for x in range of 10. Like how much more readable it is than this. We have to go for each line and then understand what the function does, but here it is so much more self-explanatory, that we have this as the return value for when x is in range of 0 to 9. Yeah, much more concise and readable. Yes, absolutely. And the list comprehension consists of brackets containing the expression followed by a for clause, then 0 or more for or if clauses. We would learn more about this. So 0 or more if and for clauses, that comes next. The result will be a new list resulting from evaluating the expression in the context of for and if clauses which follow it. For example, this list comprehension combines the elements of two lists if they are not equal. Yes, this is a list comprehension, and it would print it because it's directly inside of the primary prompt, so it would print it. Let's just go through this and see what it would print. This returns a tuple of x and y for x in the list of 1 2 3, and for y in the list of 3 1 4 if x is not equal to y. So here we have two for loops, and x goes from 1 2 3, iterates through that list, and y iterates through this list. And for every iteration, for this would be n squared, because there are two for loops, just like nested for loops, where n would be the length of the lists. And if x is not equal to y, it would put the value in this tuple format. So 1 3 1 4 2 3, you see for this list of tuples, none of the values in the tuples are same, because we had this condition at the end of the list comprehension that x should not equal y. So that's how we get this tuple list of tuples, and it is equivalent to this, which is much more confusing to understand, but this is concise and readable. Yeah, much more concise and readable. So for x in the list, for y in this list, if x not equal to y, just append to this original list. Does the same thing, but in much more complicated way to understand. Note how the order of for and if statement is the same in both snippets. If the expression is a tuple, so this expression right here in the previous example, it must be parenthesized. Yes, so tuples, I forgot that tuples come next, or we have already talked about them. yeah, tuples come after this, but for you to know, mm, yeah, tuples can also be just assigned to, let me just show you. We don't actually have to create a file for this, we can just do it in the terminal. We haven't looked into the terminal, right? So let's do it. So if we do type of 1 and 2, whoops. So if we do a type of, let's just do a variable first, x equals 1 and 2, and if we do type of x, it is a tuple. So tuple can be defined as parenthesized. I mean, it can be parenthesized, it can't be as well. So this is a tuple without its parentheses. But if we try to print a tuple, so print x right here, it would print it as a tuple would normally be. So with parentheses and comma separated values, just as a list. But tuples are mutable. We can change the values. Tuples are mutable. Lists are, sorry, tuples are immutable. Yeah, we can't change tuples. We can change a list. Tuples, yeah, we can't change those. That comes next. Actually, I just wanted to show you that x comma y within the parentheses is tuple syntax, but it must be parenthesized, because I mean, we can have it not parenthesized as well. Right here, as you saw, that this is a tuple as well. Type of x is a tuple, but for this inside of a list comprehension, it should be parenthesized, because then it won't know like what to return. It would confuse between x and y, like what to return, x or y. I don't know. Python would throw an error. Yeah, so that's that. What is this? Yeah, this has a syntax error, because we are trying to return a tuple of x and its square for x in range of 6, but we don't have it parenthesized, so it would return an error. Tuple must be parenthesized, or yep. Create a list of 2 tuples like numbers and squares. Yeah, this would do it. And what do we have again? Create a new list with values doubled. Yeah, this would be the tuple list comprehension for this. Apply function to all for x in vec. If, yeah, we can add a condition to the return, and then it would return the elements which satisfy this condition. So that's that. The absolute value of x return, yeah, apply a function to all elements. It is this one. So return absolute value of x in vector. So vector vec is this list defined right here, and we return the absolute value, so it would get rid of this minus symbols. So these won't be negative values. We would get the absolute value, which just gets rid of the negative symbol. So that's why we have this list for this list comprehension. Call a method on each element. Weapon.strip for weapon in fresh fruit. Yeah, so for this list, it would just strip it of the spaces on left and right side. It won't do it for this space right here, because it is inside of the same string between two non-white space characters. So it won't strip it of this. It won't strip it of this space, but it would for the left and right strip, I mean white spaces. Yeah, this I just explained. Flatten a list into a list comprehension with 2 for loops. Yeah, so we if you have a nested list, we can flatten it. So return num for element in vec, so it would return a list. I mean, these are nested lists. So if we just had it if we had just this in the list comprehension, it would return us the lists inside of this nested list, and then we add another for loop. So we then play with this, and for num in elim, so for these lists we would have num extracted from them, and we return num in the like new list, returning from this list comprehension. That's why we have the flattened list right here. We are just flattening this 2D list into a one-dimensional list with this list comprehension. That's list comprehension can contain complex expressions and nested functions as well. Yeah, it can. So what is this? We are returning a string from the rounded value of pi and I. So yes, I for for I in range 1 to 6 we are doing this. So rounding down the value of pi to the ith decimal, so and returning it as a string. So this list would contain 3.1 first, because the value of I is 1 for the first iteration. So it would just have one digit after the decimal. It would go on till 5. So here we have 2 digits after the decimal, 3, here 4, and here we have pi with the value of 5 decimal places, value pi with its value till the 5 decimal places. So yeah, that's it. And nested list comprehensions, these are interesting as well. So if you want nested lists, we can do it with nested list comprehensions. So for nested list comprehensions, the initial expression in a list comprehension can be an arbitrary argument including another list comprehension. So whatever is before these for loops, there can be multiple for loops, multiple if statements, as we saw in the actual list comprehension bit here. Where was it? Yeah. So for and if statements which will follow it, there can be multiple of them. And so just before this, there can be any arbitrary value which is returned, including another list comprehension. So a list comprehension can return a list comprehension which then returns something else that would be put into a list. So here for this example we have a 3x4 matrix right here, and the list comprehension right here transposes the rows and columns of the matrix. So if you know about transpose of a matrix, it just swaps rows with columns. So here we have three rows and 4 columns. It would then have 3 columns and 4 rows, and it would just look like this. So 1 5 9 2 6 10 3 7 11 4 8 12. That would be your new list like 2D list, and the matrix would have been transposed. So how this works is this nested list comprehensions always work from the outermost list comprehension and go to the innermost list comprehensions. And so this would work as for I in range of 4, so 0 1 2 and 3. This would then like for the first iteration of the outermost list comprehension, I would be 0, and then this would go into this list comprehension for the first iteration of this for loop, and then it fetches row from the matrix, and row from the matrix would be this right here, and then it would return the ith element of the row. So for first iteration it would be 0, so this would return row 0, which would be 1 right here, and then it would do this for like I is equal to 1 2 and 3. First it would do everything inside of this list comprehension for the first iteration of this loop. So I would then like this would return another row like this row, the second row, and then row 0 would be 5 for that iteration, and then it would return another row which would be the last, and it would also do row 0, so index 0, and it would return 9, and this whole statement then would return this list, which would be the first list, and then this iterates for one more iteration, and then I becomes 1, it goes on for all the rows that fetch me the first element of all the rows. So it fetches 2, 6 and 10 for that iteration, and then we get it as a list inside of another list, which would be written by this whole list comprehension. So just by this comprehension, this list comprehension, we get these lists, and these lists are put into another list, which would be by this uh, outermost list comprehension for this example. So as we saw in the previous section, inner list comprehension is evaluated in the context of the for that follows it. So it is equivalent to this right here, and this just means that the innermost like the inner list comprehension would like it would run for like this for loop would be nested inside of this for loop, and it would behave as a nested for loop. So this condition would run however many times this for loop runs for just one iteration of this condition. That's how nesting works in for loops, right? So yeah, that's it. And yeah yeah so here transpose list is just initiated for I in range of 4. Transpose dot append the list comprehension of this thing, which is row I for row in matrix. So for row in matrix, it would just return a row, which would be this right here, and then for the range of 0 to 4, which would be 3, because this is exclusive, we would then return the 0th element right here. So it would append 159 for the first iteration for like each row. So yeah, this is the like, I mean, this still has a list comprehension, but this is half for loop and half list comprehension. But if you wanted in a true for loop form, this would be it. And this is much more like, you can read it, but if you know how to read nested list comprehensions, that would be much more readable than this, like concise and readable, as we discussed list comprehensions are. So for this range, we have a transposed row right here, which would be for that iteration of the loop, because it is inside of a loop, so it would be initialized as an empty list each time. So it would just append the ith element of the row to the like transposed row and append it to the transposed matrix. So that's how we get this. In the real world, you should prefer built-in functions to complex flow statements. Zip function would do a great job for this use case. So what is this? If like zip not sure what this does. I'll have to look into this. So yeah, let's continue to the del statement. There is a way to remove an item from a list given its index instead of its value. So you can just remove the item and not the index. So if you were to remove the index, you would have to replace it with something else instead of that value which that index had. But you can use the del statement to completely remove it from the, like, just remove the element from the list and not replace the value in its index to something else. This differs from pop, which returns a value. Del statements don't return a value. They are used to remove slices from a list or clear entire list, which we did earlier by assignment of an empty list to the slice. Yeah, so remember we did something like we assigned a from start of 2 to 4 to an empty list. So that would get rid of this slice from the actual list, but we can just like use the delete statement, del statement, before this to then do what we previously did, just a concise way, and like the actual good way to do it. Yeah, del also can be used to delete entire variables. Yes, it can be used to free up space for a variable which we don't use. Referencing the name hereafter would raise an error. Yes, it would. We'll find another uses for del later. Yeah, it can be used to delete objects as well, instead of just like deleting slices of list or deleting lists and variables. It can be used to delete objects and yeah, much more. Tuples we would see in the next section. So that's it. Thanks.